Today we're going to talk about profit, cost, and revenue. Profit occurs where revenue is greater than cost or where the difference is greatest. So profit is equal to revenue minus cost. Notice the cost function is greater than the revenue function until we have an intersection. And that's called the break-even point, and that occurs when X, or the quantity, is equal to 82. Profit occurs, here is our revenue function, so our revenue function is greater than our cost function, so after 82 items are produced, then profit begins to happen. Prior to that, the cost function is greater than the revenue function. Also, maximum profit occurs when marginal cost is equal to marginal revenue. This means that their slopes are equal at that point. The marginal cost, C prime of Q, is the rate of change of the cost function. The marginal revenue is equal to R prime of Q, which is the rate of change of the revenue function. There will be less profit or negative profit if 50 items are produced in the picture. So if 50, I go up and I see I'm on the revenue function, which is below the cost function, so there would be negative profit. There would be more profit if there were 82 items, more than 82 items produced. Now, negative profit, you really cannot have negative money, but you can be in the hole. You can owe someone. So in this case, revenue is less than cost function. There had to have been some money that the person who is owning the business put in to the business. On page 199, problem number 3, we have the revenue function and the cost function, and we want to know the quantity at which the profit is maximized. When we hear the word maximize, we think derivative. So take the derivative of both equations, marginal revenue and marginal cost, and set them equal to one another and find the quantity at which profit is greatest. So profit is equal to revenue minus cost. Profit is equal to 450Q minus 10,000 plus 3Q squared, that quantity. And then we plug in the 75 from the quantity to find our maximum profit. Is $6,875. Now let's look at table 4.2, which consists of the cost and revenue values. So we want to know the Q value where the profit is maximized. So we want to find the greatest value between revenue and cost. So when I look at my profit, I see it's negative until I get to 1,500 items. And then I see my profit is 2,000, which is greater than these. So that's where profit is maximized given these quantity levels. So it looks like the maximum profit is 2,500 items that are produced and sold. So what is the price of the product? We take the revenue and divide by the quantity. So the revenue at 2,500 is 7,500. Divided by 2,500, that means that we are selling the item at $3 each. What are the fixed costs? Remember, the fixed costs are the costs when you produce nothing. So when Q is equal to 0, our fixed cost are 3,000. That is also called the initial value. On page 200, let's look at problem number 10. When we look at the graph shown, approximately what quantity maximizes profit, and we see that cost equals revenue when Q is 1,000 and Q is 3,000. So between Q is 1,000 and 3,000, profit occurs because the revenue function, or the marginal revenue function, is greater than the marginal cost function. However, the greatest or maximum profit is when Q is 2,000 because that is where minimum cost occurs. Number 11, you can read through that. Number 18, we'll talk about the demand function. Is price is equal to this function where Q is the quantity of the goods sold for P dollars. write the revenue function. The revenue function, remember, is price times quantity. So if this is the price function, we're going to multiply that by Q, and when we multiply it, we get a polynomial. So find the quantity that maximizes revenue, take the derivative of the revenue equation, and we will see that the marginal revenue function is 45 minus 0.02 Q, and that's 2 times 0.01, and 2 minus 1 is 1. We set that equal to 0 to find the quantity, and it will be 2250. We plug that in to our Q as our Q for our P, so we will know what to charge. So $22.50 is our value. We plug in 2200 for our 2250 for our quantity, and we find out we have a revenue of $50,625. The demand function, P is equal to 400 minus 2Q, where Q is the quantity of a good sold for a price P. And I think you can follow that one. Now revenue, in this case, I'll read you the problem on page 200. It says, at a price of $8 per ticket, a musical theater group can fill every seat in the theater, which has a capacity of 1,500. For each additional dollar charged, the number of people buying the tickets decreases by 75. What ticket price maximizes quantity, maximizes revenue? So we have the quantity function here. 1,500 is the number of seats, but if you charge more than $8, you're going to decrease by 75 seats. So we're going to multiply that equation out, and this is our new quantity equation. Quantity times revenue times price is equal to revenue. And we have 2100p minus 75p squared. Marginal revenue would be 2100 minus 150p. So set that equal to 0 and find that the price of $14 is the price that will maximize the revenue.